Hello everyone, my name is William Lenzaisky and I'm from Team Orange, and my other team members are Ryan Cruz, Luis Andrade, Tarindu Lokukatagoda, and Nandini. So before I jump into the content of the presentation, our group would like to express our gratitude for the other team who have given us positive feedback or even criticism that help us be better in the project. So yeah, we would like to just throw it out there. And let's talk about the presentation itself. So the presentation is going to be compilation of the work that we have done from sprint 1 until sprint 6. So yeah, uh, here's just the overview of today's presentation. So first thing, I'm going to be talking about the project management side and just about how we use Jira to manage our project and all the deliverables that needs to be submitted and stuff like that. And I'll also be talking about the analyzing fuzzy database. So in the beginning of the class, we were given a task to, familiarize ourselves with how the fuzzy database works, how fuzzy logic works, and we have to come up with recommendations using pivot table and stuff like that. So I'm going to be talking about that, and Luis is going to be talking about how we expand our database, like OES4 database, like insertion of like million records and stuff like that. So Luis is going to be talking about that, and Tarindu is going to be talking about the distributed database itself, like how we, after we have the database expanded, how we split everything in like regions and stuff, and then create users, and also like the security hierarchy and stuff like that. And I'll also be talking about how the queries are different before we expanded the database, we before we distributed the database, and after we distribute the database. And after that, Ryan's going to be talking about the use cases that we implemented in Power BI based on the queries that were given to us. So yeah, let's jump into the Trello board right now. So if you look at our Trello board that is on the IT 544 Trello page, you can see that all of our videos from Sprint 1 up to Sprint 6 are all there. So if you want to refer back to that, you can. All the links are posted in the description box. And yeah, here's our PERT chart. So the PERT chart itself helps our team to visualize the order of tasks and sometimes like the milestone and like the phases within a project itself. So it really did help us to know, so that we know where we are in the project, what are the things that needs to be submitted when and stuff like that. So um, due to this current situation with the pandemic right now, there are a lot of things that needs to be changed to our PERT chart from the previous sprint. So this is our updated PERT chart. As we know, there are certain stuff that we did not cover in the end because of the pandemic. But yeah, here's our updated PERT chart, starting from just familiarizing ourselves with the Jira as the project management tool, and then analyzing the fuzzy database, do some reverse engineering with the database exploration, and just basically understand the fuzzy logic itself and come up with the recommendation. We also did some database expansion to the OES4. We distributed the database, and then until we have the final product ready in Power BI with all the queries with the distributed database. So let's talk about the roadmaps. So for the roadmap, it's pretty straightforward. In the beginning, we have Jira setups, and like the deliverables are all throughout the entire class, and also like the basic database from the fuzzy logic, and just basically understanding how each table works, what is the content of each table, how the relationship from one table relates to the other table and stuff like that. And then we have implemented some Power BI use cases to come up with recommendations. So we had that over there in the beginning, and we did database expansion with the million plus record, do the distributed database design and the implementation with the queries, and also the final database, distributed database Power BI. So here's the look of our roadmap, and there are a lot of like parallels and stuff, but most of the time, one task has to be finished before the other task starts. So yeah, and here's the look of our burn down chart. I've only included 4 of the 6 burn down chart that we have. So basically, in the beginning, we didn't really understand how burn down chart can help us in managing our project. So if you can see the first burn down chart, we actually did not set any story points on any task that we have. So that's why our burn down chart is literally flat. and you can see how we improves from the first sprint to the second sprint to the fourth and the fifth and the sixth. So we know that from the first sprint, based on the feedback that we're given, that we would have to assign story points depending on how complicated a task is, and that will be shown in our burn down chart. So after that, we have just improved, and I personally feel like we have done enough work on our Jira part, on our managing our project, just to know where we are in the project and stuff like that. So next is the sprint one planning. So I'm not gonna talk about how we do the sprint planning for each different sprints that we have, but then I just want to show you guys how we did it for sprint one. So for sprint one, we know that in the beginning of the class that we would have to familiarize ourselves with Jira and how we can use Jira to manage our project, setting the roadmap, posting backlogs, and all those stuff. And from there, we also at the same time we also have to do familiarize ourselves with the database, right? We want to take a look at the reverse engineering and just to see how one table correlates with other table, how their relationship works and stuff like that. And we also developed scripts for the queries. There were 14 queries that time, and we implemented a pivot table and just basically come up with a recommendation of which mem set and set role that we have to choose in order for it or the fuzzy logic to make sense in our employee decision database. And we also plan to have some deliverables that we were gonna submit, and we had to plan some things about that too. And then in the end, we did the video presentation itself. So here's just the look of our backlogs. So basically all the stuff that I mentioned before for the Jira and database, everything is we listed in the backlog, and we just assign it to like a specific sprint that we are starting. So yeah, and then here's just the chart, the Gantt chart and the burn down chart, and also like our board itself during sprint one. So as what I've said before, the burn down chart really help us to show the actual velocity of the sprints that we have accomplished as a team, and also inform us when our team progress is behind schedule and entering the danger zone or not. So basically, danger zone here means if we have any blocks that we have to carry to the next sprint and stuff like that. So yeah, it really did help us manage our projects. So in the beginning, we had to study and analyze the fuzzy database. There were like fuzzy components where there's a relational database inside, and in the active database, the MV, and also the fuzzy logic itself. And also in the first recommendation, we had three different fuzzy attributes, right? The sales, the number of orders, and the number of products. And the categories itself, there are poor, below average, average, above average, and excellent. And these categories is assigned to specific range. So basically, if we are talking about specific fuzzy attributes like sales, if their sales are around this range to that range, then it will be considered as poor, below average, average, above average, or excellent. So we had to analyze all those stuff, how each logic works with the fuzzy attributes, and how we can come up with like the fuzzy categories and stuff like that. So next here is just the first few queries that we did. I mentioned before that we had to do 14 different queries to come up with a recommendation. So the first one is list employees including their number, last name, first name, and decision made about their performance. So basically all of these are like set rules. So like there is a mem set and set rules. There are 12 different combinations. So and we would have to choose one that is best to our scenario, to our business problem. So we did actually come up with a recommendation, but then here is just a quick overview of our SQL queries in the beginning with the pivot analysis and how we come up with a recommendation. And next is just I just want to show you guys the sprint retrospective sprint to planning. So in the retrospective sprint document, we want to have information about what actually went well from the first sprint, what didn't go well, and then what improvements we can make for the upcoming sprint so that we can become better. So here's just a quick overview of how we actually plan stuff and document stuff in order to manage our project well. Here's just a view overview of like our Scrum meetings. So we track what's done, what's in progress, and what's to do. And if there's any block from the first Scrum meeting, we have to make sure that we solve them, or like we actually do something about it in the next Scrum and stuff like that. So this Scrum meeting notes actually help us figure out what needs to be done in each different sprint that we had. Um, so in the beginning, I mentioned about how we analyzed the fuzzy logic and we had to do some reverse engineering for the FAOES database and just to find out what relates to what. For example, the WTNet here, there's no actually description of what WTNet is, but as you can see, it actually relates to a lot of tables. So there are a lot of relationship with the other table to the WTNet. So we know from this diagram or data model that WTNet is basically the foundation, like the compilation of all other database that we had. So it's like a very important table. So we had to go through each of the columns, just make sure what is what and where is where, and then what needs to be changed, what needs to be fixed, and stuff like that. Here's just some use cases. So as what I've mentioned before, we had the WTNet table that we want to come up with like few different use cases that could help um, users, and also we want to implement it in the dashboard. So here's our 5 different use cases that we think would be important. So the way we construct use cases is that we find what is the problems that they do every day, but then we just want to simplify that in one different dashboard that they can just view, and then they can figure out all these things, all these use cases that's important to them. So yeah, as what I've said before, we wanted to have those use cases and build it into different dashboard. So like for example, as a board member, determine which branch brings the most revenue per employee. So as a board member, you would want to know which brand has the gives you the most money, right? Which brand actually that break even and stuff like that. So here's just a quick overview of our dashboard that we created. We have very cool visualizations, and you can see we have it for each different queries that we have to, like I think we had 14 queries. So yeah, it's like query 1 until query 14 over here. So next, Lewis is going to be talking about the OES4 expansion strategy, and I will be back later on in the video to talk about the how we did queries before we distributed the database and then after we distributed the database.
I'm going to present the OS4 expansion strategy in here. We have four strategies. First one is migrate relevant non-fuzzy tables from Oracle to SQL Server. We didn't have any. We are going to use the SQL Server most of the time, so we import our Oracle all the Oracle tables to SQL Server using SSIS and also using the uh, export wizard, import wizard. And the second strategy is create dummy data using Excel and also using the Python script. We use Excel to create the dummy data for customers and employees, and we use Python script to create dummy data for orders and order line table. And we randomize customer orders, employee sales, and we use new customers, employees with respect to existing dataset. Use and we use stored procedures to update our some orders table. You can see in here we updated some use auto stored procedure to automate the shipping method, tax status, tax amount, and shipping charges and total amount using stored procedure. Uh, and here's our data dictionary for the OS4. And here's the dummy data for employee and customer. We create these using the Excel as I said earlier. And also you can see the insert statement here. We use the random function in here to create a lot of time to generate those data. And here's the data for order line and order table. And you can see there's more than 1 million record in here, and also you can see the for the order line table, and also you can see the more than 300,000 orders in here. And this one is especially selected for the 2020. uh, so so we have the uh, data up to 2020 from the 2000. And I will go and show you guys how did we generate those data using the Python script. And here we first import the random, date time, pandas, and numpy module, and also date time. And we create the function in here, refresh data, and bring the all the data we have in our uh, as in the CSV file for orders, order line, customers, employee, product, and shipping method. Uh, in, and for if you need to create the data for 2004, you need to put the refresh data 2004 in here and run this one. And we create six another function to get the random product and connect to Oracle. If we we do not use this one, uh, if we are not going to use this one like CSV file, we can just connect to the Oracle and get the latest product number or order number or customers, random customers in here. And you can get in here random customer function, and you can see it in here get random employee function. This one we created for the to create the get random date for the orders table, and this function we create the to get the random quantity for the uh, order line table. And this one is the product head data frame using create using this one. And in here we are creating new orders, and in here we are creating some in here we are creating new order line, and this function is for the create the new orders. And when it's created one order, it's going to the new order line and create another 2 to 3 order line. And after that we export all the uh, data back to the orders or order line just like CSV file, and we use that data to import to the we use those orders and order line table to import and get the data from to the SQL server. And in here the next thing is the so after we expansion our database has more than 100 and more than 1 million record in our order line, and we have more than 300,000 orders. And we use automate in using the Python script, and the orders and order line have the data integrated in here. And as I said earlier, we try to use the step procedure as much as we can, but some step procedure didn't work for our OS4 because I think it maybe it has a lot of data. So we had to left some field, and but after that we use Python to create new data for that those columns. And here are the final OS4 database in SQL Server. And we use this one to generate the Power BI, and also we after that we distribute all the tables, and we use this database to create some views uh, in other servers.
Hello everyone, I'm going to show how we could connect MS SQL servers. We have 5 MS SQL servers and we are going to connect all other servers to server 20501 server. Ultimate goal in here to create a distributed database system. Then we can access data from other servers, data from the other servers using 20501 server. You can see there's a 5 servers 20501, 20500, 503, 504 and 505. In server 20501 has 3 database: Central, Mankato, Fuzzy Table and OS4. OS4 database vertically horizontally fragmented and replicated to the other servers and also to the Central Mankato database. You can see it does has all these tables now, but we replicated into tables into here, and and region 1 has in the 2050500 server, and region 2 data has in the 503 server, region 3 and 4 in the 504 server, and region 5 and 6 in the 505 server. And each region contain these views: customer, employee vertically for the each region, order line, order, product, promotion, quantity discount, return category, return product, and tax region for each region. You can see if you open here the same views. And central Mankato has, I already told these, have these tables replicated from the OS4. So we no longer need the OS4 database. So to link the server or region, first you need to go to the server object and click the plus sign, and you need to click and open the link servers. And I already link all these below for servers. You can see it in here. These servers I link into here. So I will delete one of that, and I'm going to delete the 20500 server. Let's say yes. And to link the server, you first need to right click the link server, and you need to click the new link server, and you can give any name in here. I'm going to give the same name as appeared in here. And if it's a SQL server, you don't want to worry about anything in here. If it's other than SQL server, you need to click the other data source, and you need to give the provider, product name, and data source. And then I'm going to go to the security section, and you can add the local login, impersonate, and remote user and remote password over here also. And I usually use this section, and I already log in all the 5001 using SA. You can see it in here, SA login. I'm going to give that login in here, and I'm going to give my password in here. And if after you click OK, it will be going to link to the server 501. You can see it in here. This server is linked to the server 20501. If you go over here, you can skip it just has the region 1. I'll check it in here. It just also has the region 1. So you can see the region 1 database having in here. And if I go here, if you click views, you can see that the same views in here has also in the here also.
Now I'm going to talk about how we implement our distributed database in this project. Before moving on, I want to start with what is distributed database. It has a system in which storage devices are not connected to a common processing unit. So each system have their own memory and the databases. So moving on to the next slide. As you guys can see here, we develop a diagram to represent our distributed database design and implementation strategy. We use a homogeneous distribution system strategy, plus due to issues with the Oracle server, we use this strategy to create our database, and that help us to easier to manage and design our database too. Plus, we use a linked server technology to distribute database among other servers. These linked servers enables you to implement distributed databases that can fetch and update data in other databases. So we were able to link 5 SQL servers. In here, 20501 considered as a centralized server, And this server has fuzzy databases and central Mankato databases. And all other servers such as 20500, 20503, 20504, and 20505, they were linked to 20501 server, and they all divide with different regions. So next slide. In this slide, with more details again, server 20501 contains only fuzzy tables, and central Mankato is a replicated table, has replicated table, and this site act as a central system to do the queries. And also it contains the employee view of the city Mankato. Server 20500 has region 1 and contains vertically fragmented, horizontally fragmented, and replicated data related to region 1. And you can see what views we have in region 1 on the illustrations. And server 20503 and has a region 2, and 20504 has region 3 and 4. 20505 has region 5 and 6, and they all contains vertically fragmented, horizontally fragmented, and replicated data. So before moving on to the next slide, let me walk you through to the SQL Server. So in here, I'm going to log in to the server 20501 and log in as a SA connect. So as you see here, these centralized Mankato and fuzzy tables are in 20501. OES4 database should not be here for security wise, so we will be hide this in the near future. And next, I'm going to show you how to test whether the servers are linked or not by using this command. So as you see here, these are the servers that are linked. So these 5 servers, it's going to show it right here. So each of these servers are linked. To verify the list of linked servers, then I will show you under server objects. If you go to linked servers, it will show you all the servers that are linked without any error. See right here. So as you see here, we already done this part. Moving on to the next slide. When giving access to the system privileges, we have to be very careful because powerful privileges in wrong hands can cause a lot of problems. So in order to protect those roles from unauthorized persons, we protect them with passwords and granting limited access. So in this example, as a user CEO, he log in as a CEO, but he's able to access only 6 tables, and he has access to perform select statements and insert statements only. Plus, he doesn't have access to fuzzy tables. As you see in this picture, this is the pop-up with an error message. So next I'm going to show you how we create login and users to our database and how we secure them. So first I'm logging to a server 20500 and user login as accountant1, connect, and then go to databases. As you see here, he's going to see region 1 only, and go to views. This is the only table that is usable to view. For the security, how we did the security on these, you go to users, under accountant, You go to properties. Under properties, you select this table. So this is the only permission that we are granted for this user. So he's able to select only. And another example, so you connect to 20500 and then as a branch manager, do the same thing. Is able to see region 1 and then go to views. Under views, he's able to view customer table, employee vertical table, audit line table, order table, product table, promotion table, quantity discount table, return category, return production, tax. Those are the tables that he's able to view. And for the security wise, go to users under branch manager, do right click, hit properties. So if you see here, select the table and is able to select only and do same thing for the employee vertical, order line, and order region, and for the product too. But for the promotion, this user are able to insert, select, and then delete. Moving on to the next example, connect to the server 20503 and log in as a sales manager. Sales manager, go to databases. He's able to view region 2 and you select region 2. Under region 2, select views. As you see here, he's able to view order line, order table, product table, promotion, quantity discount, return category, return product. And same thing for the security. If you select user, sales manager, hit right click, properties. So these are the tables that he can view, and these are the permissions that are granted. So far he's having select, same thing, and yeah. So the promotion, he has granted for insert new rows into a table, retrieve data from a table, delete rows of a table. Okay. Let me do another example. 20503 for another user, another login. This time I'm going to log in as a programmer 2. So as a programmer 2, for region 2, select views. So this user able to view order line table, order table, product table, and then the quantity discount. Same thing, security, go to users, programmer 2, right click, properties. These are the tables is able to view. And if you select the table, you will see what are the permissions that are granted. Order region 2, product region, quantity discount. Yeah. So that's pretty much it. So that's all for me. William will explain it to you guys how we implement queries using open queries. Thank you.
So after we talk about how we distributed our database into 6 different regions, actually, that is saved under 5 different servers that we have. So we only have like 5 SQL server as of right now. So as what's mentioned before by one of my teammate, server 20500 has region 1, server 20503 have region 2, server 20504 have region 3 and 4, and server 20505 have region 5 and 6. So in our queries for distributed database, we want to make sure that we query it based on each different region. That's why the query is pretty long, because we wanted to access different servers and stuff. And it is also important to note that I log in with the SA account, which has all this service linked to it. But then if I query it based on with the specific account, like for example, we create an account for system analyst, they won't be able to view the whole database. They only get to see a subset of it. So yeah, these queries are the queries that we generated from the SA user, which means like the system admin that can view the whole thing basically. But yeah, one of the queries that we did for the distributed database is to list all employees, which includes their employee number, last name, and first name, that have had more than one order per year. So I just want to list all the employees that have had more than one order per year. So here's the on the left picture is the query. As you can see here, we try to access each different region separately, and then just union all of them together. But then we also make sure that it's distinct, and so that we don't have any duplicates and stuff. On the right side is the result. I just want to let you know that the result is 240 records long. And how we select employees that have had more than one order per year is to actually group it by a yearly, and then having the count of or the order number larger to 1. So that's how we actually query for the first query. The second query is to list all employees, their number, their name, their last name, their first name, and their order number. As long as they have had more than 3 products in their order per year, I would want to list all of them together. So this query is actually pretty confusing, just because one employee can have many order numbers, right? And each order numbers have the distinct order lines of how many products they sell in that order. So if we just want to know which employee have had more than 3 products per year, we only have around 240-ish records. But then since we also want to list the order numbers, we have a lot of them right now. So for example, our order numbers actually from the beginning is like from 1,000 to like 150,000, I believe, because we had to add 1.5 million records in there. But these are just some of the order numbers that have more than 3 products in their order. So yeah, we group it by year too, as usual, because we want to know their products, the number of products in their order per year. So we want to make sure that we group it by the year, and then having the count of the order line as long as it's more than 3, and then union all of them together. We also did a select distinct for this one, for the overall query too, on the top here. I think it's the first 3 lines of code, and that's just to remove all the duplicates if we do have any duplicates. But then we also make sure that we cross-validate our result with our previous query when we did the query without the distributed database, and the results is still the same. So that is good. And let's continue to the next query. So the third query is to list the top 10 employees with their number, last name, first name, rank, and total gross sales. So I just want to change it real quick here that it is actually 5 employees that we want to rank. I mean, we could do more than that. I cropped it accidentally, but yeah, if you run this code, and then if you just change the number 5 to 10, you can get the query for the top 10. But then the list of the top 10 goes from top to bottom. So for example, number 5 is actually rank number 1, the one that have more gross sales. So this is how we do it. We basically did a lot of we basically just list employees with their total gross sales first, and then we group it by year, and then we just sum it all together to find their total gross sales. And this is the query to do that, and then we just select the top 5 based on their total gross sales, not just by their gross sales without being it grouped by the year. But yeah, this is what we do, how we did it. And one of the main challenges here is just to actually not only query it for one region, right? Since it's all distributed and stuff, I want to make sure that I cover all the regions from region 1 to region 5 and 6. And the next one is the actually query number 9. I'm not going to go through each of the query. You can find it in detail in the report. And also all of these queries, the result of the queries can be viewed in the Power BI dashboard. And all of those dashboard have the same result as what I have right now in the query. This just to helps us cross-validate the result that we have in our Power BI dashboard. So the query number 9 that I did was to list how many products are sold for every year per product category. So if you look at the right side, in 2006, memory card gets sold 6,883 times. So there are 6,883 products sold for memory card in 2006. The list does go on for all the product category that we have, but yeah, this is how we do it. We just basically go through each region and then find the order, the specific items, and then look at how many items are being sold per order, and then we just group it by whatever order, whatever product category that we have, and then sum it all together. So this is a summary of what we have. And yeah, the complete list of the queries can be found in either the report and also the Power BI dashboard.
Now we'll talk about our Power BI implementations of non-fuzzy queries. We completed all 9 queries and included them on a dashboard. Because many of the queries are best seen as lists, the dashboard is not very attractive. However, it shows the important information included in the requirements. Query 1. List the employees that have had more than one order per year. In our dataset, all the employees have had more than one order per year, so they're all listed. To add more value to this query, we also included the average number of orders per year for each employee. So for example, Harrison Heisler averaged 40.91 orders per year. We can also see the total number of orders averaged per year company-wide, 8,698.41. So this includes all of the employees in the company. Query number 2. List every employee that has had more than 3 products in their order for every year. To implement this query, we used a matrix which represents a pivot table of sorts, where we can click on the year of interest, 1999 for example. We can see all the employees' names along with their employee number and the number of products sold. We decided to include all the entries in this data table because there were only a couple instances where an employee sold less than 3 products every year. We decided it was more valuable to include all of these instances. However, this would be easily changeable using a filter. Query number 3. List the top 10 employees in terms of their total sales. For this query, we created a rank measure using DAX. So we can see the DAX formula here. And this allows us to filter by rank. So our filter over here, we want to see the bottom 10 because we want numbers, ranks 1 through 10 in our visual, which you can see reflected. Query number 4. List the bottom 10 employees in terms of their total orders. Again, we used a similar rank where we ranked by the number of orders placed this time. In our filter, this time we want the top 10 because the 10 worst employees will have the highest rank number. We see there are actually about 12 employees listed here, and that's because there's a tie at rank 229 out of our 240 employees. Query number 5. This query is actually pretty similar to query 3, except instead of looking at the top 10, we want the top 25% by gross sales. So to do this, we take advantage of our rank measure again, except this time we create another measure called top 25%. And for top 25%, we set the value equal to 1 if their value is in the top 25%, otherwise it's just 0. Then in the visual, we filter by this measure, requiring that the value is 1. For query number 6, in fuzzy analysis, how many employees were in our fuzzy decision and are they still working for us? We're going to focus on this query so we can see it a little more clearly. And we altered this query a bit because we did not fire any of our employees, so they are all still working for us. Instead, we are showing the average gross sales by the fuzzy decision category they were originally in, along with the number of employees that were in this category originally. This might be valuable for someone who is trying to determine if their fuzzy categories are correct moving forward. Of course, our data is randomly generated dummy data, so the insights are not all that impactful. Nevertheless, we can see how this might be helpful in the real world. For example, the employees who would have gotten fired under our chosen rule decision and memset have averaged over 348.8 million in sales for this company. And the employees that would have been given no decision have averaged 339.6 million in sales. Now, a cool thing we added to this visual was the company-wide average, which is shown by the red dashed line. So this allows the viewer to see how each decision group compares to the rest of the company. For example, the ones in give raise and gift to employee actually ended up performing the highest above average, while no decision was below average. Query number 7. Based on each state, how many employees are in each branch for every year? For this query, we used a stacked bar chart. We can see Minnesota has 3 branches, with each branch's numbers given at 24, 22, and 14. We can also see the branch number in the tooltip. Also, we can easily see that Minnesota has 3 branches and way more employees than any of the other states. Query number 8. We'll focus on this query too. Based on employee position, how many employees are in each different branch? For this, we used a clustered bar chart. We see each branch on the x-axis, and the position of each employee is divided out into our legend colors. We can compare the shapes of each branch to each other and easily see any branches that look peculiar. For example, branch 100 has significantly less sales reps compared to most of the other branches. And finally, query number 9. Based on each product category, how many products are sold for every year? We took this a step further by dividing it out by brand so we can see Microsoft, Samsung, and Sony. We used a stacked bar chart where we can hover over the segment of each category to see the total quantity. We also see that Microsoft has a lot higher quantity of products moved than Samsung and Sony. For example, Microsoft has over 7.8 million products of the Xbox category sold by this company. Now, the last cool thing I'm going to talk about is the play axis that we added, which can be seen here. The play axis is a free custom visual installed from Microsoft's store. We can hit play and it will iterate through the years and update accordingly. It starts at 1999 and it moves through. It spends about 2.5 seconds on each year and then moves on to the next year. Now I stopped it so it shows all data again, but I'm going to pause it and move forward to one of the later years where we have our database filled out. Then I'll wait for the visuals to update. Now we can see what's going on a little more clearly each year. You can see all the charts have updated to reflect the data from just 2008, which could be extremely useful. And then when I hit stop, we go back to showing all the years again.